Hi guys, this is Med Berry and welcome to my channel. In today's video, we're going to be reviewing a lot of different EKGs. I would recommend that when you see a new EKG, just pause the video, try to answer it first yourself, and then once you're ready to hear the answers, you can unpause. So let's get started. So in the first EKG, I love that they give the rhythm strips because that's where I like to start, and specifically lead 2. The first thing I'm going to look for is the rate. I can eyeball the rate by just counting the boxes, so 300, 150, 175, 60, so it's somewhere between 75 and 60, which is normal. Or you can also count each of these QRSs throughout this rhythm strip and then multiply it by 6 to get the most accurate heart rate. The next thing you want to look for is this normal sinus rhythm. And normal sinus rhythm, is there a P followed by a QRS followed by a T wave? And I see that. I see a P, QRS, T, B, QRS, T. So this is normal sinus rhythm, which is great. The third thing I like to do is really quickly, eyeball my intervals. And my PR interval, remember, needs to be less than one big box. It needs to fit in one big box or in 0.2 seconds. And my QT interval needs to fit in 2 big boxes or 0.4 seconds. And this looks great. Okay, still I want to go up and confirm, my axis is this normal axis deviation. And to do that, that would be my step 4, is to check for the axes. I can use the eyeball method, where I can just use my lead 1 and AVF. So if lead 1 is positive, I use the positive end of lead 1, which is 0 degrees. If AVF is positive, I use the positive end of AVF, which is 90 degrees, and my normal axis I know will fall somewhere in here, which is normal. The other way I can use is I can use the isoelectric or net zero method. For net zero method, remember, you first need to know what leads are perpendicular to each other. And that's the easiest way, is to make an X. So lead 3 is perpendicular to lead 4. Lead 1 is perpendicular to AVF. And lead 2 is perpendicular to AVL. So what I'm going to do first is I'm going to first look for my isoelectric lead, or the lead that is most net zero. What that means is that it needs to be as much above as it is below. Okay, and in this case it's lead 3. Once you've identified your isoelectric lead, you go to the perpendicular lead and check whether the perpendicular lead is positive or negative. In this case, AVR is negative. Remember that the normal axis for AVR is here at negative 150 degrees. So the negative end of AVR will actually be, if we just extend it back down here, which will be like positive 30 degrees, and this falls in my normal axis. So this is a normal axis ECG. The last thing I want to do, just to confirm, is look at my V1, because V1 gives you so much good information. And here I see a P, I see my QRS, which is narrow, and I see a T wave, and it's not too deep, it's negative, all the things that I'm looking for in V1. So this is great. This is a normal ECG. Okay, let's move on. So they don't give me a rhythm strip, but that's okay. I'm still going to start from my lead 2, since that's my favorite. And then what I'm going to look for here is the heart rate, which is the first thing. And the heart rate is 300, 150, 100, 75, 60, like about 65. So, approaching bradycardia slightly. And the next thing I want to look for is rhythm. Do I see a P, QRS, T, P, QRS, T? Yes, I see rhythm. So this is normal sinus rhythm. The third thing I like to do is look at my intervals. And the PR interval in this case is greater than 1 big box. So that's concerning. Okay, this is a PR elongation, okay, or prolonged PR. My QT fits within 2 big boxes, which is great. So it's not a long QT, but I do have some PR prolongation going on here, or elongation. V1 looks good. So this is really the main thing that's going on. And what this is called, it's called a first degree heart block, where you have a lengthened PR interval. And how there's a little story to learn these heart blocks, and this is how I was taught. So I'm going to share this with you. So the P wave is you, the QRS is your man or your significant other, whoever. Okay, so you're the P wave, QRS is your man, and the PR interval is the time your man takes to come home. okay? When you have a first degree heart block, this is you, that your man stays out later at night, but comes home, okay? So this is you, your man stays out late at night, but comes home. So your PR interval, he's always late, but he always comes home, okay? He's always going to come home, and that's what you see in a first degree heart block, okay? Only a lengthened PR interval, no drops in QRS. Okay, let's move on. So I do have my rhythm strip here, which is great. And I know this isn't very clear, but what you're seeing here really is just squiggles in a QRS, squiggles, QRS, squiggles, QRS, squiggles, QRS. And this is your AFib, okay? When you see squiggles in QRS, that's an AFib. And you can see this pretty much throughout, squiggles, QRS, squiggles, QRS, okay? So this is AFib. Let's move on. So give me lead 2, not very clear, however, there's an elephant in the room, okay? And you can see that right here. So anytime I have ST elevations going on, I call them elephants in the room, okay? So elephants in the room, ST elevation, lead V1 through V4. These are my anterior leads. These are my septal leads. Okay, so this is an anterior septal MI. And you're probably gonna see an occlusion in the left anterior descending artery, which is a branch of the left coronary artery. Moving on. So what I see here is, I'm going to start with my lead 2. The first thing, the rate is extremely slow, right? This is 300, 150, 100, 75, 60, 50, 45. So extremely bradycardic here, and that's what I'm seeing in this EKG. I see extreme bradycardia, no other abnormality as such. Moving on. So they give me my rhythm strip, and it's lead 2, which is great. The rate looks about normal, right? 300, 150, 100, 75. So rate is normal. However, I do see these random empty spaces, right? So these are like gaps. And they basically tell me that there is a dropped QRS. So you have the P wave, but you never got the QRS. Same here, you got the P wave, but you never got the QRS. So I know this has to be some kind of a heart block, okay? How to tell what kind of a heart block is, you mark the gaps, and then the best way is to look at the PR interval right after the drop, and the PR interval right before the drop, and compare them. So the PR interval after the drop is about that much. The PR interval right before the drop is about that much, okay, in length. So you can see that there has been some lengthening of the PR interval as you kind of went forward, progressed towards the drop, right? So you see a progressive lengthening of the PR interval. So it's that much, it gets slightly longer, slightly longer, slightly longer, and then much longer, and then you finally drop. Okay, so this is your second degree heart block and Mobitz type 1, okay, where you see that progressive PR interval lengthening. And the story goes like this. This is you, and your man comes home on time. The next night, he's out for slightly late. The third night, he's out for much late. And the fourth night, he doesn't show up at all. Okay, so on time, slightly late, much later, and then drop. So this is your secondary Mobitz type. Secondary heart block, Mobitz type 1. Now this is not as bad because you were kind of expecting him to not show up, right? You know he's been out late progressively every night, and you kind of expect him to not show up one night. So this is not the worst thing. It can be both physiological or pathological. But we're not like super concerned, okay? So next here, rhythm true. And I see these beautiful sawtooth pattern waves, right? Sawtooth pattern like that. And this is my A flutter. Okay, so what I'm going to start with here is my rhythm strip 2, but it's kind of funky looking, right? It doesn't give me a lot of information, but that's okay. There is definitely something crazy going on here with these leads that I need to address. So let's see if I can use this to figure it out. So I have my deep QRSs, but then what are these? These are my really tall T waves, right? So this was my QRS, and then I have a really tall or a peaked T wave. And this is something you see with hyperkalemia. So it's actually kalemia here. So it's a potassium disturbance. You have too much potassium, because of which you see these peaked T waves. The best leads to identify these peaked T waves are your V2 and V3. They usually can really spot any of these disturbances with potassium. Okay, so what's going on here? I see lots of squiggles. So lots of squiggles, no QRSs. This is VFib. Remember, AFib was squiggles with a QRS. Squiggles with a QRS. This was your AFib, right? VFib, just squiggles, no QRSs. Moving on. Let's see what's going on here. So starting with lead 2, the rate is, wow, bradycardic, right? Bradycardic, very slow. Let's look at my waves. Is this normal sinus rhythm? I see a P, I see a QRS, I see another P, T, P, P, QRS, T, P. So if you see, there's no pattern to this, right? The P waves are kind of doing their own thing. The QRSs are doing their own thing. So this is a 3rd degree heart block, okay? And this is very concerning, right? We have to treat this with a pacemaker. And what you basically see in a 3rd degree heart block is that the SA node is not talking to the AV node. There's no communication between the SA and the AV node. So the SA node is setting its own P waves at a rate of 60 to 100 beats per minute. And the AV node is setting its own QRSs at a rate of 40 to 60 beats per minute. And they're not communicating to each other. So you see these random P waves and the random QRSs when you look at your rhythm strip. Okay. So love that they give me the rhythm strip. Let's start with lead 2. So I have a P, I have a QRS, but it's this weird kind of sinusoidal kind of wave, right? This is actually called a U wave. Okay, this is where your T wave looks more like a U, and it's very clearly seen in V3. You can see this clear U right here, right? Kind of in V2 a little bit, V4, V5 are also great to kind of see this U. And this is a U wave, to be honest, you know, it's a progression of either hyperkalemia or hypokalemia. They can both progress to U waves. So this is more of like a chronic potassium disturbance. In a more acute potassium disturbance, remember with hyperkalemia, you see peak T waves. With hypokalemia, you see flat T waves, more acutely. More chronic, they can both progress to, U waves. Okay, let's move on. So again, clear elephant in the room here, okay? I know they don't give me a rhythm strip, but you can't ignore these, okay? And your leads 2, 3, AVF, and if you see, they make a shoe. So this is your inferior leads, and this is your inferior MI, and this is probably an occlusion going on in your right coronary or your right marginal arteries. Let's move on. No rhythm strip, but that's okay. I'm gonna go to my lead 2 always, and then let's see what's going on. So, whoa, what's that? It's an inverted P wave. And if you go up to lead 1, there's actually no P wave at all. So when you have no P or an inverted P, that's your junctional rhythm. Okay, so this is your junctional rhythm with a no P or an inverted P, and essentially your SA node has completely failed if you're seeing this junctional rhythm. Okay, let's see, we have only lead 2 here. This P wave, clearly something up with this. So QRS is good, T wave is fine, but the P wave is notched. And anytime you see a notched P wave, it's a sign of left atrial enlargement. Okay, and left atrial enlargement can be many reasons, but one of the common ones can be mitral stenosis, among others. Okay, let's see what's going on here. Again, no rhythm strip, but that's okay. Quickly check at lead 2. It's normal sinus rhythm. However, there's, again, elephants in the room, guys. So these giant SD elevations, and if you see, really, there's also some SD elevation going on in 1 and AVL as well. So lead 1, AVL, V5, and V6. So 1, AVL, V5, V6 are your lateral leads. So there's a lateral MI, but there's also some mixed kind of anterior septal MI going on here, okay? So it's kind of like a mixed anteroseptal lateral MI going on here. Remember that if there's a lateral MI, you probably have an occlusion in the left circumflex artery. And if it's more of these anteroseptal leads, it's your left anterior descending. And they're both branches off the left coronary artery. Okay, let's see what's up with this one. Not very clear, but it's okay. I'm still going to start with my lead 2 here. And if you look at lead 2, this is, let's check, okay? So that's my P wave. That's my P wave here. QRS, T, P, QRS, T. Okay, so I do see PQRST kind of repeating itself, so it's normal sinus rhythm. However, the rate 300, 150, 175, 60, so kind of slightly bradycardic, or on the lower end of normal. And if you look here, let's quickly look at our intervals. So your PR is within one big box, which looks good, but your QT is actually much bigger than 2 big boxes. So it's almost 3 big boxes. So this is your long QT. Okay, this is your long QT. Remember that long QT, many reasons can cause long QT. You can even have antiarrhythmic drugs that give you long QT. But you also want to remember that you have some, congenital channelopathies, some mutations in your ion channels. And there's 3 types of channelopathies. There's IKS, IKR, and INA. And these 2 are loss of function mutations, and this one is a gain of function mutation. Okay. And you can remember this as, I guess the PG version of this is, I want soup right now. Okay, so SRN. Okay, let's move on. So let's start with my rhythm strip here. Let's see what's going on. I have a P, I have a QRS, and I have my T wave. I have a P, QRST. So I do see normal sinus rhythm. Let's check the rate, 300, 150, 175. So normal rate, okay. So the next thing I'm going to do here, once I have looked at my rhythm strip and the intervals look good and the rate and the rhythm looks good, is I'm going to go look at my axes, okay. And when I check my axes, my lead 1 is positive, which is great, but my AVF is actually negative here. So I'm actually going to be looking at the negative end of my AVF, which is minus 90 degrees. And this tells me that I have a left axis deviation this time. Okay, there's really 2 reasons for left axis deviation, or the more common ones, I'd say, either left ventricular hypertrophy, or you have a left bundle branch block. Okay, and to look for both, I have to go to V1. Okay, so that's my next step. Once I know it's left axis, I look at my V1, and what you're seeing in this V1 is you're seeing a wide QRS, and you're seeing an RS pattern. So there's a wide QRS, and you have this RS pattern to V1, and this is indicative of a left bundle branch block. Okay, let's move on. So here, let's see what's going on. So lead 2, PQRST, PQRST, no QRS drops, looks good so far. Okay, so let's see what's next here. So let's look at the rate, 300, 150, 175. So rate is normal, rhythm is normal. The next thing I want to look at really is my axes. Okay, so 1 is positive, but AVF is negative again. So that again puts me in this left axis deviation LAD column, quadrant. Okay, so I again have a left axis deviation, and again, you're either looking for a left bundle branch block or left ventricular hypertrophy, and you need to go to V1 to figure out what's wrong. So my QRS is narrow this time, so this cannot be a left bundle branch block, and I don't see the RS pattern. So this probably is a left ventricular hypertrophy, but let's check. How do you check for that? You count how many boxes the QRS is deep. So in this case, 4 big boxes down. And then you look at leads V5 or V6. You can pick any one of these really. In this case, I'm actually not going to choose V5 because I can't really see where it ends. So I'm going to go with V6 instead, but it really doesn't matter which one you pick. And then you can count how many big boxes this is tall. So in this case, it's 1, 2, 3, 4, 5 big boxes tall. So you're going to add these numbers together, 4 and 5, and that gives you 9. If you ever get any number greater than 7 big boxes, that confirms left ventricular hypertrophy. So this is my left ventricular hypertrophy. Okay, moving on. So the first thing I'm really seeing here, okay, is, I'm going to go to my rhythm strip. And I'm seeing these random QRS drops everywhere, okay? And you know what I'm going to do when I see my QRS drops? I'm going to look at the first PR interval right after the drop and the PR interval right before the drop, and I'm going to compare them. So in this case, this is about that big, this is about that big, and they both look the same, right, in length. So when we don't see that progressive lengthening, we see the same PR interval repeat itself and then a random drop. This is our 2nd degree heart block, Mobitz type 2. Okay, and the story for this goes is that this is your man comes home every night at the same time. Okay, he's home every night at the same time. And then one day, all of a sudden, one night, he just doesn't show up. Okay, and guess what? This is actually more concerning than Mobitz type 1, because in Mobitz type 1 you kind of expected him to not show up, right, the 4th or the 5th day, because he was staying out late and late and late every night. But in Mobitz type 2 he's coming back home every night on time. So this is kind of concerning. Okay, so Mobitz type 2 is actually, we also treat this with a pacemaker. This is always pathological. We treat this with a pacemaker, and we're concerned because this could anytime progress to a 3rd degree heart block. Okay, let's move on. So we have this beautiful EKG next, and when you see really tall, really fast heart rate, and really pretty peaks like this is your monomorphic VT. Monomorphic VT. It's monomorphic because you can see it's like the same pattern kind of repeating itself. Okay, you see the same P waves again and again and again and again. Okay, so this is monomorphic ventricular tachycardia. Next, so no sinus rhythm strip, but that's okay. I'm going to start with lead 2, and I see P, QRST, P, QRST. However, they point out the P waves, right? So that's nice. They're kind of telling us what's wrong. What's wrong with these P waves? Oh, that's not a P. So what's wrong with that P wave is they're tall. We have tall P waves, or peaked P waves this time. If you see peak P waves, that's a sign that there's a right atrial enlargement going on. Okay, remember a notched P wave was a sign of left atrial enlargement, but a tall P wave like the one you see in this EKG is a sign of right atrial enlargement. Okay, perfect. Moving on. So let's see what's going on here. Let's look at lead 2. The rate seems to be, slightly fast, I guess. So, or right about 100. Which is, upper end of normal, but that's okay. And there's not much I can tell really from my rhythm strips. I'm going to go up and I'm going to check for my axes. Okay, lead 1 is positive and AVF is also positive. So this time I'm normal axis. So that's fine. But again, I do want to look at V1 because it can just tell us so many different things. So I'm going to look at V1 just to rule some things out. And when I see V1, I see that wide QRS, and I'm also seeing a specific pattern here. I'm seeing this RSR pattern. So if you see this RSR pattern, that's a sign of your right bundle branch block. Okay, remember, if you see a wide P wave like that, this is your RS pattern, which is a left bundle branch block. But if you see this RSR pattern, this is a sign of right bundle branch block in V1. So wide QRS with the RSR. Okay, moving on. Okay, so this is a polymorphic VT. And you can probably understand why it's polymorphic and not monomorphic this time. because you see like that variation, beat to beat variation. Okay, next let's look at what's going on here. So lead 2, the rate is 300, 150, 100, about 90. So the rate is fine, slightly, slightly elevated, but that's fine. I see rhythm, I see PQRST, 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 so that's good. The next thing I want to look for is my axis. And this time, lead 1 is negative. So this was our positive lead 1, right? But it's negative. So I'm going to look at the other end of lead 1, which is at negative 180 degrees. So this is where I am with lead 1, or plus minus 180 degrees. Let me fix that. Plus minus 180 degrees. Let's look at what AVF is doing. AVF is positive, so AVF still goes down. But this time, this puts me in my right axis deviation. Okay, I'm in the right axis deviation quadrant. So what I'm going to go now is I'm going to go to V1 and I'm going to check for my QRS, and my QRS is positive. That is enough information to know to confirm your right ventricular hypertrophy. If V1 is positive, that confirms your right ventricular hypertrophy. Okay, and the right axis deviation supports the right ventricular hypertrophy, which is great. So this ECG, you're seeing right ventricular hypertrophy. Okay, moving on. So let's see what's going on here. I'm going to look at lead 2. Well, 300, 150, so greater than 100. Well, this is tachycardic, okay, for sure. This is tachycardia going on. But, let's just make sure to see we don't have any other abnormalities. It's tachycardia. It's normal sinus rhythm because there's a PQRST, PQRST. Lead 1 is positive. AVF is positive. This is normal axis. And V1, the QRS is narrow. And I don't see any abnormalities with V1. So this is just, plain old simple tachycardia. So I believe that's, we have one more. This is a repetition. This is our, remember, small squiggles is VFib. So I believe that's it. Yeah. So we got through a lot of different EKGs, and I hope this was helpful. Thank you.